Okay, now it's recording. That I will finish with the last lecture. Then I will, because I have only just one slide. Then I'll talk a little bit about the exam setup, and then we will do the final lecture also. We should have enough time to finish them all. Just because this one is not too long. So the idea of this table that we forgot, like we didn't have time to finish. So what we talked about last time was about this kind of public goods. And you remember that some of the public goods are like non-excludable, meaning that the difference is that, that more than one person can use it. And can they use it at the same time? Is it available for everybody? And so when we look at this table, we have like this small matrix here. And the idea here is that so there are two categories. So the first category is that do we need to compete to get this? So basically that's the idea, that are we competing, or, multiple of people can use the same thing at the same time. And the other criteria, well, that's not the truth. So the consumption is excludable. Does it mean that, no, let me go back. So the consumption is excludable. This means that can we use it at the same time? And do we compete means that is there room for everybody? So whoever wants can do it. And the question is like some of the public goods and not public goods. Basically, so this is the excludable parameter, and this is this non-revolvers that we had here. This non-revolvers, it's a very difficult word to say, meaning that, we don't have to compete. There is enough for everybody, basically. Let me see. Maybe I will give you one example, or maybe you can give some ideas of maybe what is something that everybody can use. Nobody's excluded. We can use it at the same time, and so we don't have to compete for it, and also meaning that that basically is that we don't have to compete and everybody can do it. So what do you think are some of these kind of goods? In a way, the title of the slide gives you some kind of hint also that, we are looking at public and non-public goods. So you can think maybe some of these either public or non-public goods, and where would they lie? So something that would go, let's say, that would go here, this no, so that everybody can use and nobody is excluded. Government services, exactly. That's a good one. Oh, so funny font, but exactly. And maybe even like like public security, public defense, some these kinds of things. Yes, anything, maybe something else or more specific, or some ideas what we could have here. This box. Maybe like simpler things, like maybe more, yes, exactly, like streets. Even maybe like streets lighting, you know, everybody's just there to this kind of like infrastructure. We also mentioned last time, remember, public, like, or the fundamental research also is like this public good. So these are like this traditionally like public goods that we can. So exactly. So we'll go back to the streets, including toll. I'll put this fundamental research here. What do you think? Where do the streets with toll go to? Which box? This left, like right upper corner, or which one is this? Like basically toll roads, like paid roads. Yes, yes. But is it so that when I'm using the toll road, then you can't use it? So the traffic jam is different. Let's finish with the toll road. We have not finished with that one. So if there is toll road, and is it open for everybody who pays basically, or is it like when I'm driving, then nobody else can drive? Let's finish the toll road, because the traffic jam is a different thing. Yeah, but these are the different things. Let's finish first the toll road and then do the traffic jam of the public roads, because they are in different. So there's no competition to enter the toll road. So in that sense, is it excludable? Then it doesn't exclude anybody. Or does it? So the thing is that we don't have to compete for it. So everybody can drive it, but it's excludable means that we have to pay for it. So it's not like open for everybody. So it's not free. So it excludes people who don't pay, but people who pay, everybody can use it. So exactly. So it is no completable. Yes. So that's true. So, oops. So this is toll roads. Now, what about traffic jams in a public road? So in that sense, it's still a public road, but so it's like we don't have, so do we have to compete now? Like it doesn't really exclude, but so, and no compete. Although this one was still for the toll road. What about public road when there is a traffic jam? Like it basically, these like open for everybody, but we kind of have to, but we kind of still have to, yeah, exactly. So non-excludable, but now with competition. And what are some other very good examples of things that are basically available for everybody, but it doesn't mean that we can get it? Do you have some other like very good examples for that? When you think about traveling, for example. Are there something else that goes here when you travel? You're a tourist, maybe? Do you encounter then these kinds of situations when it's open for everybody, but you kind of have to fight your way through? Do you have an idea what I'm thinking about? Not really airport, because that's not really like it's more like a service. I think it's a bit tricky to, yes, so places to be visited. So what I'm specifically aiming is, what do we call, like, everybody. So basically what I mean is like famous these sightseeing spots. Like if they're open for everybody, but it's so crowded that you might even not be able to see it. So this is what I actually mean. So that, like, this is really hard to get your hand to. What about else? Let's go to these toll roads. What are some other services that that they are in a way excluded, that you have to buy it, but it doesn't matter, like basically like limited amount of people can use it at the same time? Do you have some other ideas what we could put here? The people typing. What type of services? Yes, exactly, like insurance. I would, yeah, like electricity, I guess, yes, in a way. Of course, if it like goes above like a certain limit, but yes, insurance is a good idea. In a sense, yeah, it's not like that when 3 people in your building already have electricity that you can't. And also all these kinds of like internet kind of based services. I think we mentioned in some of the lectures also. So these are also like, you know, like when you have like Netflix or something like that, then, you know, it doesn't really matter. We can use it at the same time when we have the subscription. Yeah, like TV or like these kinds of paid services. And what about this here? We have nothing yet here. So the service, or like the things that there's like a competition, and you know, you kind of have to like pay for it. So meaning that, you know, it's so what are some of what are some of these things? Public transport. Yes, that's a good one. Like if it's but it's also, you know, of course it depends on different cities, you know, somewhere it's like free or like you have some but overall, yes, like it fits like a certain amount of people, and you know, if you have to pay for it. But what is like maybe even like a better example, or like a simpler? Yeah, like renting private apartment, and of course, just like, you know, it can't be that many people rent at the same apartment. Yes, but even when we even take it like more simple, like the simplest things. What do you think? Yes, it's like exactly every private good. Yeah, like if I buy this piece of bread, then you can't get the same bread anymore. Or like if I buy ice cream, so exactly like exactly this groceries, a private good, exactly. So these are like the simple. So we are competing, and if there's only one, then there's like basically like, of course, and like individually there is only one of each. There can be similar things, but that's not really the same. As for example, for Netflix, we are exactly using the same thing, and so that's a little bit of difference. And I think these are the main ones. So I'll make a screenshot so that I can. So this is it for that lecture. And before I'll go into the last lecture, it will be quite short. Also, there are 2 things of business. So the first one is the presentation that you are doing next week. And it would be nice if you would do like a PowerPoint presentation that it's like nicely presented, like to the client, and give and it's good to present not just the results, but like your like logic behind it and like reasoning behind it. That would be very useful, and then we can ask questions, so everybody is like listening in, and you can divide it either that one person makes the whole presentation, or maybe you want to divide it into different sections, that somebody's presenting like maybe like a general idea, and then somebody is explaining like the specific aspect. So however you feel the best. And so this is what you kind of have to do, and then you will be graded in the end, right? Like not right on the day, but afterwards. I think that's how it. Yeah, I did it last year. And for the exam, now you can see the exam questions. Oh, sorry. Just not enough oxygen here. So you will see now in like this first section in Moodle is the exam questions. And I think I can't share my screen, but maybe I can share this window. For some reason, I can't share the full screen. I have all kind of security. But window I can share. Let's see. No, it completely disappeared on me. Every time they're doing some kind of an update. Oh, no, I think actually. Are you seeing? I don't know what you are even seeing. I did open the window, the questions, but I don't think this is what you are seeing. Let's see. I think it even doesn't allow me to share. Let me try shares, allow to share window. Share this window, share. Sorry, I don't know where it went. Yeah, it's not coming up for some reason, but I'll download it. Give me a second, and I will share it with you. I think it's just better. Let me see. Then we are all on the same page. Okay. It should come up. Okay. So I hope you can now see the questions, or like the oops. Don't want to share anymore. It wants to keep sharing, and let's see. What's happening? I'll stop sharing my. So these are the questions. They're uploaded, and how the exam is going to go. So it's an oral exam, and it has 3 different parts. The first part is that you will get 2 questions out of these 14. You will have a little bit of time to prepare your answer, so you don't have to like immediately, you see the questions, I hope, yes, that you don't have to immediately like that I'll ask and then you have to answer. You have a little bit of time to prepare It is a no material exam also, so you can't use any materials, but you will have a minute. We will do it in the same place that we are right now, so you can you will have like maybe like 5 or 10 minutes, and then you will explain what you think, and it will give me an opportunity to ask for further questions. So in that sense, it's good that you don't have to worry that have you talked about all the aspects of that question, because I will ask more if I feel like you haven't covered the question, you haven't covered everything sufficiently. So I'll ask additional questions. So I think in that way, it's better like as an oral exam, because in a written way, you just write down what you know. And so it can be a little bit of disadvantage. And each of these questions will be 20 points. And the exam overall is 80 points, and you get 20 from your presentation or the homework next week. And then what happens is that this is where the oral part stops, and then you will have 2 questions in like multiple choice answer questions in the Moodle system. Basically what happens that when we start to take the exam, you will open the exam and you will get, I don't know what questions you're going to get because they are random. So there's like all these 14 questions are already in Moodle, and it like randomly selects 2 questions for you. So I don't know which ones these are. And then you will also, and then once we have discussed those, I will mark them later on like manually there. And for the grade, and then you will get 2 like similar to these. So these multiple choice questions, you don't know exactly what the questions are going to be, but the topics are the ones that we have covered, obviously. So nothing too extensive there. And then also you will have to do like a small calculation where you can use an Excel file. And then for that one, you also have, for these ones, the multiple choice each question is 10 points. So it's like 10%. So they are quite heavy. So make sure that you really take your time to answer those. I'll think maybe I'll add a few more questions, and maybe I'll have 3 questions, and that each is like fewer points. I'll see what my thinking is a little bit, but previous years it has been like that. Well, they aren't very hard anyway, so but you still should take your time. And then the small calculation, and you see here that this calculation, the examples are really very similar to what's coming. So you don't have to do like the whole full calculation, but just like a part of from the bigger picture that we have had before in the seminar. So it should be okay. There are some slots in Moodle. Let me check if they are full. So some of them are already picked. And if you would like some other date, then just email me, and I'll see, what I can do. That maybe I can, or not maybe, I can definitely find some other opportunities too if I don't have any other commitments at the same time, so we can figure it out. So you can just drop me a message or an email, and I can offer some other dates also. And I will, after this period is done for June, for the beginning of June, I will put up another set of dates, and once everybody has covered. Do you have any questions regarding the exam? See people typing. And if you have any questions regarding the questions, you can also just write me a message and I can guide you to like the best answer. Of course, you can't do that. You answer all these 14 questions and then you send the answers to me and you ask if these are correct. The whole exam time is, let me see, I think there is enough time to, let me see what the time limit is. There is no time limit, actually. You know, basically take your time. You can't really do it like the next day, but for the same day, there isn't really a time limit in the exam. So the Moodle will not really close on you. So the multiple choice and calculation. So you will have enough time. There is, because I haven't put the limit in Moodle because I don't know how long the oral part takes. Oh, sorry, for May 26, both schedules are at 2 p.m. Let me see. Really. Let's see. Oh, wrong course. Let me check. I can change it for the 26th. Oh, yes, indeed. Change them around. Yes, so thanks for that. Yeah, it's a bit tricky to do at the same time, but not really impossible when, but yeah, if you want some other dates around, like some other times around these dates also, I do have some availability, but yeah, you can definitely ask. We'll figure it out. What's the best option? And let's continue with the last part of the course. It's not very long. It's actually quite short and kind of tries, and it, in a way, it doesn't have too much new information for you. You probably have heard some of these aspects in different lectures that you are taking because it's quite strongly related to metrology overall. Or maybe those of you who are taking measurement and law, then also you might find some familiar things here. But overall, there isn't really a very good material to, I think even like when we started, we said that it's quite hard to even, you know, evaluate what are the influences of the measurement infrastructure on like economy, because it's, in a way, it's like everywhere and in different ways and in different scales. Like for some aspects, it's like the main part. I'll give you some examples, and for some other parts, it's just like, you know, it's a part of an everyday life that we don't really think about it, but it actually does have an economic like influence. And of course, one of the main idea why we even have this kind of infrastructure, like similarly why we have this metrology, you know, like SI units and standards, is that because we are so global, and for the measurements, we want that, you know, once they are measured, then everybody accepts these measurements, and that we don't have to do like double work, or that there are double standards somewhere, you know, that when when your product is accepted in some place of the world, you would like it at least in some part be acknowledged. Of course, it's not all the time. There are some regions, like for example in Europe, we have different directives for like electronic products, so you can't really sell anything that you would like. So you would have to meet these requirements, but at least you don't have your product. It doesn't have to be tested in Estonia, and when you want to sell it in France, then you would have to have it tested in France, but it's enough to have it tested in one of the European countries and it's accepted everywhere. So this is a little bit of a background for some of you who is not familiar with these kinds of like limitations to public goods, like not public goods, but to trade. And of course, from like our everyday life, what the measurement infrastructure does is our safety, you know, that the roads are safe, or that of course the bridges are safe, you know, that it's or like when you go to the doctor, that analyses that are done or the drugs that you are taking are safe. So all of these kinds of things. So so the influence sometimes is, you know, the influence might be on your health, but it would still have an effect in the long run on the economy, because, you know, the healthier the people, the smaller are the costs for the health system. So that's why it's it's difficult to give an evaluation, like a monetary evaluation, you know, what is the impact of having all these kinds of like measurement infrastructure. The general infrastructure in most countries, and again, for some people it might be a little bit familiar, have taken previous courses, or so that's perfectly fine. But the idea here is that you see different lines here, that there are different levels of these kinds of infrastructures. We do have some kind of like a government level who is like guiding this and making sure, you know, that everything is in place, and some kind of ministry. And then we have some kind of like a national system. So the ministry is basically just saying, you know, this is what we want to have. We want to have this infrastructure. And then there is like this support for this metrology infrastructure that comprises, you know, different like accreditation agencies, National Measurement Institute, so NMIs, maybe you have heard. So these are the organizations who are responsible for like SI units in the country, different calibrations, and legal metrology agencies that are like dealing with measurements that are related to taxations. You know, when you are buying petrol or gas, you know, you have this special tax for gas that you are paying for the government. So that all these kinds of measurements are done in accordance, that because there is monetary value there. So these are like the main organizations that are part of the government or like the national system. And then, of course, we have like the private part of the metrology infrastructure. So it is like different different laboratories who provide accreditation service, accredited services. They are doing calibrations. You can do like your water analysis when you want to, for example, check your water. And of course, non-accredited laboratories also, they do offer some kind of services also, and not all the measurements in that sense have to be accredited. Of course, they might not be as widely acknowledged, the results that are provided by the accredited laboratories. But so ideally is that the labs are accredited, of course. And this part, you know, runs in like this supply and demand curve that we have talked about, that, you know, if there is a need for a specific service, then the service is provided. So the government doesn't have to provide these services. You know, when you want to check your, like, let's say you want to check the water in your home, it's not the government's responsibility. They are making sure that the water that comes from the water plant has to be clean, but what ends up in the final, so, you know, you can do the analysis, and or you want to calibrate, like in university work, we have out these analytical scales. We want to calibrate them. Of course, this is like a private service. We will have to pay for that calibration. and all the scales in the supermarket and all of that. So these have to be, so this is like the private services. And just like briefly in Estonia, how it is set up is, so you see it's very similar, that we have the ministry, and then we have these three, I would say even a little bit like pillars. So we have the accreditation body, which is government-owned company. We have the Central Office of Metrology. So basically National Metrology Institute is part of that. And it also has some designated institutes. And so these are related to SI units and how they are, managed in Estonia. And so it doesn't necessarily have to be Metrocert, which is the Central Office Metrology. So it can be some designated institutes also. And this Legal Metrology Authority. So in Estonia, the name has changed also a few times, but the Consumer Protection and Technical I can't see that I have this. Let me see. It's behind. You probably see the name. So anyway, so they are making sure that things are safe for people. And this is also where you can actually go to, complain when something is wrong, that you think that some companies are not providing services that they have to, like the quality is not as good, or maybe they are even not providing, you have paid, but you are not getting your services. So this is also part of the legal metrology. But they have a lot of inspectors. So they like go to the supermarket and maybe like buy random groceries and then check if these meet all the requirements, and they check like railroads and all of that. So Legal Metrology Authority. And then we have different type of laboratories. So testing and calibration laboratories, conformity assessment bodies, and like different certification laboratories, verification laboratories. So, and these are private. Of course, in Estonia, Metrocert also offers calibrations, but this is not like part of their government work, but they're just because they are also government-owned company. They still, want to earn some money, so they do offer services to like regular markets, or to regular people, like regular markets also, and want to calibrate your temperature, like devices, or like thermometers or like manometers or something like that. And of course, the verification laboratories are, all the heat meters, the water meters that you have in your, like where you live, like either you rent an apartment, or you like in a hostel, or like student facilities, these are all these devices that also have to be, calibrated, or like, well, verified in that sense that they are showing in a correct way how much water you have used. So this is really relates to that. And this can all be like private. So it's like a private market, whoever wants to and makes it the most efficiently, you can do that. Now, when we come to measurements, then of course we are thinking about, like the infrastructure, so measurement instruments, where are these coming from, and who is responsible for providing them. And there is like this kind of, how to say, there are different ways. Of course, government does has like their own laboratories where they do have their own instrumentation. Like when the water has to be tested, like the drinking water, or like environment or food, then like the health board or the environmental agency, when there are certain let's say, regulations coming from the Europe or from the law, then in a specific, how to say, there is a certain responsibility of the government to provide these instruments. Or maybe they are contracting somebody to do it and they have to buy those too. But of course, when it's like part of the, not like maybe like public benefit, then it's up to the, you know, if you want to provide a service, then you have to buy those instruments yourself. But of course, at certain level, and like university, when we talk about like research, then of course, you know, government really doesn't buy these research instruments, but the government is supporting and like giving grants for different research projects. So in that sense, they are supporting, because like we talked about, you know, like fundamental research, nobody really wants to, you know, it's very difficult to do it like as business. And I think there was recently an article about the rector candidate for, I think, I don't know, it wasn't the rector candidate, it was just some kind of an academic who was talking about this funding, and what he also said that even now, you know, if an Albert Einstein would like to get a funding in Estonia for his fundamental research, he wouldn't get it because it's not practical. So it is getting even hard when the times are tough, then even to get funding from the government for the fundamental research is quite hard, because we want to get like fast return from our investments. And the fundamental research is definitely not that field where you would get like a fast results and fast like return on your investment. So that's why overall, like markets as themselves don't provide any these kinds of like public goods. We would call these, you know, they are like similar to public goods. But now we can have a little bit like a small table that we can fill out. So remember when we talked about the externalities of like general goods, you know, like when there is a concert nearby your house, you can listen to the free concert, but it can also be a noisy. And now when we think about this measurement infrastructures, that we have those, we have, you know, government provided laboratories or even private like measurement infrastructure overall, then what do you think are some of the like positive externalities for you when you are not like in direct contact it, but what is like the overall benefit to the society of having all these kinds of very high-tech measurement infrastructure and all these legal systems and these calibrations and accreditations and all of that? What do you think are some of the positives of that influence you like in a indirect manner, you think? Let's start from the positives. I see people typing. It's good that there is such a setup of all these kinds of like, yes, exactly. So the uniformity, so we have like good quality and the products are like reliable and exactly so. Exactly, you go to the supermarket, you know that when you are weighing 1 kilo of bananas, you know that you're getting 1 kilo of bananas. So of course it is because there is this system, you have like this impact on you. Anything else good about it? I kind of mentioned some of the things a little bit also. Do you think are some good things? Maybe some more like, yeah. So yes, international trade, and we would like to say like via this harmonized standards. So in a way, it's like we could say it's like a fair trade for everybody who's like participating. So you know that there is like a fair playing field that somebody can't sell like cheap things that are dangerous. So you know that. So I think in a way that's definitely. That's definitely true. Any other positives? Do you think it also means that when we have this kind of the quality is one thing, but I would also say that I would say that in the long run also things are like more efficient and there's more innovation because we want to make things like better, and I would say also that. And maybe one more thing that's like definitely a big thing is, you remember I mentioned like the bridges, and so like the safety and health part for sure is, you know, when we have better water testing, we know that the water is cleaner, or your like the bridges are safer, and your health is checked better, you know, you have some kind of disease. So definitely like health and safety aspects. But what about some negative things? What do you think that this brings about, that we have this kind of measurement infrastructure? Are there some bad things also? Do you have some thoughts? Yeah, so exactly. So it can be high costs, definitely. And not only for like smaller businesses, but overall, you have to, you know, it costs money to make sure that some things are compliant, and in a way also there's like more paperwork, you know, you have to, you know, now you want to go to the market, and you know, there's some results you have to show, so there's like more paperwork also, I would say. Of course in certain places it might limit, but you know, it can go both ways, that you might have to do that. And the high cost of compliance, but it can also lead to more expensive products. So again, like the positives and the negatives can go both ways. Okay, I hope this kind of helps a bit. So I have one more graph that I want to explain. So the question now here is that, you know, remember when we talked about even like analytical measurements and their efficiency and the instruments that you are using, and that they can have an effect, you know, like we would like to have like more automatization, you know, that it would be more efficient. And Now, when it comes to like the general aspect of this instrumentation, is like when you think about you are producing something, and let's say you are producing I don't know, like even some kind of food, and then you would have to test that food, to make sure that it meets the requirements, that it's safe, there are no contaminants except, like when you have like maybe you're like making, I don't know, like yogurt or something, then at certain intervals, you have to check the product. You are not checking each product, obviously, because then you would have nothing to send out. But there is like, you have to check certain amount of products. And of course, the more products you are testing, then the risk is smaller that, when you have, let's say you have 100 products in your like a batch, and if you check like 50 out of this 100, then the risk is very small that something is wrong with these samples, these products that you didn't check for. But of course, it's very costly to do that. So you would like to check the least amount of, and of course, it also costs to make those analyses. So if you check less of the samples, then there is higher risk that something is wrong with some of the samples, because you maybe only checked one of hundreds, and then there's like bigger risk that something is wrong out of some of the samples out of this 99 that you didn't test. So we have this uncertainty, and of course we would like to find this like a medium, like a sweet spot where we are testing enough that the risk is quite small, but still, that there's no point really testing more, because the risk is then you might check more, but it doesn't really change. So the curves here, these curves mean here basically that, when you have an instrument and you are spending quite, the less you are spending on tests, of course, the bigger the risk, that's definitely sure. But now you see that there are different curves, and these different curves are related to different type of instruments. So it might be the same setting, but your testing systems are different, and the curve shape depends on the instrument. And there is this line here, and you see, so this spot here, let me mark it. So this spot here is like this sweet spot where it doesn't really make any sense to spend more on the testing, because the win is not really, you would spend quite more on the testing, but the risk, you see that the risk is like plateauing in a way, that it just doesn't make any sense to spend more, as opposed to, up here, that a little bit of more, so the slope is steeper. Is that how is that way? Well, but the slope, so even a small change in the cost of testing, the risk decreases significantly. So this is what you would want. So let's see. So you see here that for example, so here it's like, it's not very straight, but that here the cost is small, and the risk is high, but maybe like this kind of a change, the risk comes down significantly. So all this difference here is the risk that is changing, but the cost that you have to pay more is quite small. That you still get the very big effect, as opposed to down here, the cost to get this same difference here, you see, I don't know, maybe like to get the same change here on the uncertainty, you would have to spend significantly more. So that's the problem. So you might have a small risk, but you have to spend a lot of money. So there's like this sweet spot. And now, like I said, then the good case, or like that, what these different curves are different instrumentations. And you see here that for the advanced systems, the cost of testing is smaller and the risk is also smaller. So the sweet spot is like on a much, so here with this almost like with the same risk, or like with the same cost for testing, the risk is, so it's almost like kind of where I draw, so like somewhere in between. So you see here that this difference in risk is so much smaller, but you are maybe like spending approximately the same. So this is why these different curves are related to different instrumentations. So you can, so the better better systems allow you to either test more, test cheaper, test faster, whatever like the specific advantage of that measurement system is. But yes, like productivity and quality probably is the better. Or like the testing itself is also, has all these advantages. So this is why we would like to have more efficient measurement systems, and I'll show, and I will give you some examples. So is that clear, or do we have? I have some examples, so maybe that helps also. But yeah, so it's not like very complicated in a way that we all can understand that. As maybe it's less, maybe it's harder to understand for people who are not in the field, but I guess as like measurement science, it's kind of obvious for you, but maybe for economy people it is not so. It's a good scheme too. Well, it is still difficult how to estimate. Like I started also that it is a bit tricky to really give like a monetary value to, like now when I have this better instrument, like what now it improves, or how much money do I save. So sometimes it is possible, of course, like remember we do the calculations, how much an analysis costs. We can kind of understand for certain things, like where we can either, have an automatic system or develop the instrument faster, or use a different method that uses less chemicals or something like that. So we can do, and then we can a little bit like in that direct manner, we can give a value. But if it's something bigger, like from the economy point of view, it's very hard to give like a value. So it is like an estimation, and a lot of estimations in measurement science, uncertainties, and so we have to deal with it. There are some examples, and one of the examples is from the 90s, where it happened that traces of cyanide were discovered in the grapes that were imported to the US. And so all the grapes were refused from Chile were refused. And what happened when the investigation started was actually that this contamination came from the laboratory. So the fault was not on the grapes, but on the method that was used, and maybe some cross-contamination or something. So, like such a big effect. And because the economy really also, depends on this agriculture, and this is a product that you can't hold on, when they are refused, they're already ready, then and nobody accepts them, then you can't, like put it in storage for a while. And for that, it was, there was a lot of loss of confidence. It was estimated that the value is $400 million, and that's like in the beginning of 90s. So in that sense, you can put kind of like a monetary value, like maybe what's the amount of grapes that were refused because of this error. So you can, I guess the negative sides probably are more easy to backtrack than maybe to look forward what would be the different effects of a certain advancement. And then another one is related to paper, and the case was that in North America and in Europe, how the paper whiteness is measured and evaluated is according to different standards. And it meant that the paper that is accepted in the North American market is not accepted in the European market. And in order to make this paper compliant to the European standard, and the change is very small, and how the paper is made, and it was that the Canadians would have to use like 65 million more on the bleach to match the standard of the European paper quality. And then what was done, basically, that the methods were compared, and visually you can't even determine this difference. And then it was resolved by just making sure that that they are accepted both, so that the Canadian paper is accepted also in Europe, and that the standards are basically equal, even if they are made, even if the standard to make them was a little bit different. So yeah, and the measurement standards also different. So how they were measured. So this whiteness. So there is an effect on this kind of like we thought it's better to have harmonized standards there. But then the comparisons were made, and it kind of they resolved it by just accepting that the both standards are okay. And I think this is quite an interesting one also, is a lot of, in my experience working in analytical chemistry, of course there are a lot of interesting fields from the science point of view and or health point of view, but one of this, maybe not surprising for everybody, but the field that's very strong on standardized measurements and standardized systems is like the crude oil and petroleum market, because there's so much money. And I mean, even now you probably hear in the news that when the prices go down, then the whole like the Russia is like in problem because a lot of money comes from the crude oil, and it's a very big and a significant market, and it's like very big part of the trade. And interestingly, one of the things is the accuracy of how to measure the water content in the crude oil. And it's important because water dissolves in crude oil. So when you are paying for your oil, you don't want to pay for water. You want to pay for the oil. And if there's too much water inside, or if it's wrongly measured, so I mean, it's okay if it's measured correctly, but the problem is that if the measurement is not done correctly, or it has too much of an error, or like here it is said that the oil company has estimated that if the water content for this one pipeline is overestimated 0.5% in water content, the loss of is $3.5 million for that, just for that small difference, overestimation of the water content. Because if it's overestimated, you will get less money for your oil, because they are saying, it's some of it is water and we don't want to buy you for the water, but so you will lose money from that business. So that's why all kinds of petroleum analysis are highly regulated, and even a lot of the parameters in the oil industry are only acceptable if they are done like with one specific type of an instrument that is from one producer, to avoid all these kinds of difference. So like I said, some standards are not even, don't specify a method, that they specify basically an instrument that you have to use for that measurement, just to make sure that there is no like difference between the measurements done in different laboratories. And you probably know by now that to achieve the exact same traceability is quite difficult in different laboratories when there are different people, different conditions, maybe a little bit different guidelines, even if the method is exactly the same, maybe different standards are used. So they are like highly regulated, so that there's basically no source of error that can't be evaluated somehow. So that's an interesting field. And this is also a very interesting example related to cholesterol measurements. You probably have heard, you're young people, but still, you know that cholesterol is quite a problematic. And it goes both ways when we are measuring cholesterol. Is that the first part is that when we have false positives, so that we are telling people that they have high cholesterol when they actually don't. So maybe they have to take some drugs, they have to, so definitely like it's cost to treat them. People have to spend time on them, like doctors and like that. And the same goes for the false negatives. If there are a lot of false negatives, then some people are left untreated, they get sick, or they, they have health problems, they might even die. So of course, this is a cost for the economy, or like the society as well. And then for that, there has been like during the years or like decades, like different advancements that have tried to increase this false positive and false negative values. And so, for example, there are these standard reference materials. So first it was like for the pure cholesterol. So the SRM stands for standard reference materials, not certified, but standard reference materials. You know, now when laboratories have like this certified reference material and it's pure, then like already you see here, like it goes down, this false positive, false negatives. And then there is like an improvement on the method. So they're like changing the method. And now they also have a standard reference material that is specific to serum. So not just pure standard, but like a matrix match standard. And the false positive rate and false negative rate go significantly down, because now you can't have any there's less risk of having matrix effects because you have a standard. So that is actually why it's very important to have like reference materials that are matrix matched, because then for like most of the people, you don't have any matrix effects. But of course, there are specific cases, and of course, things can still go wrong. People are not identical, obviously. So there's still some left. And again, and then in the 1997, again, there's like this specific, like an analyzer that helps to have like this, there are different types of cholesterol, to be like more precise there, that it's not just one cholesterol, one is more dangerous than the other one. So you see like this constant improvement that will have in the long run a benefit to the economy, to the society, when we are improving this kind of measurements. So that's why there are all the time, even if some methods are still, it seems like they are like accredited, they are standardized, it doesn't mean that there is no room for improving them, even if it's not made, that the general benefit is there. And if the more people it has an effect on, then obviously the bigger is the monetary value there. There are some estimations that what could be the possible impact on the GDP annually for the related to the measurements. And you see here for the different countries. And why do you think, like Germany, for example, has the measurements have quite a big effect on the GDP as in comparison to Italy, for example? Why do you have an idea why that could be? What is Germany famous for example, and maybe what's Italy famous for? Do you have some thoughts here? I see people are typing. Italy economy is, yes, probably raw material based. I think that's definitely. But Germany does have a lot of raw materials also. So it's not only that, because they do have a lot of coal and also. So it's probably one of them. But maybe also think a little bit what is made out of these materials, or yes, but why Germany? So this is the question. Why is now, because there is added value to Germany products, but why? Not like I'm looking for the why. What is the reason? The high tech is definitely, but even I don't know if in Estonia at least, or in Europe, there is like this saying, like German preciseness, like German cars and like the motors and the German cars are like high, like always appreciated much more. And so it's even less than high tech. It's also like related to that. They really are extremely precise in their measurements, and their products have very high quality because they have this tendency to really focus on this, and they are a very big market. But what is the main product of Italy? Like, maybe it's a little bit simplistic. I hope there are no people from Italy, but what are the main that we are? Tourism, and what else? Yeah, Germany is not very big on tourism, definitely. Like, you know, it's not Italy, definitely. And what else, maybe? From like the producing point of view, but we are like mostly know about Italy and maybe less about value, less about Germany. Very simple. This is the main products coming from Italy. Fashion, that's true. That's actually very good. Yeah, and there the measurements are maybe not the like the main. Yeah, so it's like, yeah, more about like design. Italy is very big on design, definitely. You know, like all the furniture, and that's like, you know, made in Italy is very big. It's more on the aspects of like visual. And what else? So the visual part, and what is something else? Very big in it, like we like very well known for. Come on, you must know. The lunch has passed, but still, what is very big? Not only in Europe, all over the world. It's also like general, but still similar to France, but Italy also. People liquor, but yeah, but maybe if you're thinking about liquor, then what type of liquor, or like some other, exactly like gastronomy, like overall, like the wines, the food, the pasta, the like parmesan, like different cheeses, the different pastas, like tomatoes. So all of these like agricultural products, and they are very strong there on their like geographical marking, that, you know, where is everything coming from, and it's like traceability related to, of course, the measurements are coming important there also, that, you know, we have analytical methods to determine like the origin of olive oil or something like that, but it is a lot of like food, and so it's not as, yeah, like somebody mentioned, is like this high tech part. That's not, the products are not, you know, in that sense, that the measurements are a very big influence there. It's definitely smaller. So yeah, that's probably where the difference comes from. I don't want to like do any harm to Italians, but Germans are definitely very proud of their like auto industry and instrumental industry, which is not the first thing in, and the food is definitely first thing, not the first thing in Germany. So there is a difference. And this is, I think, the last slide. So the I kind of talked about previously, you remember that I said that the different parts of the measurement infrastructure are like, in a way, like funded differently, or they are part of the, you know, some come from the customers, or like from the public side, or like the private side, from the private sector, and some of the funding comes from the government. And you see the lines here are the solid lines are the ones where it's fully funded by the government. Of course, so the ministry is fully funded by the government. The office of like NMIs are fully funded by the government. like the central office. But of course, there are services that are either partially funded. So this dashed line means, an arrow means that it's partly. So for example, the accreditation body is partly funded by the government. So like the core of their funding comes from the government, but the customers still have to pay for that service also. So it's not free for you to get your labs accredited. So you see here, like the down we go on this, like where we started with the UK example. The down we go, the more it is even like fully funded by the customers. And then, yes, the government offices can be either fully funded. And of course, those that have to be like impartial are government funded, and the ones that, you know, offer some kind of services. So for example, the National Metrology Institutes are fully funded, like the measurements that they are doing are fully funded, like the calibrations that they're doing are fully funded by the customers. But the partial funding is in that sense that we even have this organization that's like partially funded by the government, because if it would be just like a general market, then nobody would open up like this National Metrology Institute, because it's not like business wise. I would say it's probably difficult to be like on the plus side with your business, like fully. So it can't be fully funded. So certain services can be fully funded, but definitely not all of them. So the government definitely supports some of the things, and maybe some of the things that are required from like the national security point of view, but there is no market from them. So whatever is like a market interest more, then this can be fully funded by the customers. So yeah, so that's and all these kinds of verification services are usually like fully funded by just by the customers, because the customers want to have their water meters, and this is a requirement that they have to do to calibrate their water meters. Then there is definitely a laboratories that can do that. Or you want to test your food or something, then yes. So this is of course you don't have to know these arrows, but you kind of have to understand like the general logic from the economic point of view, why certain organizations, how they would be funded. Just, I guess, based on what we have talked about, it should be quite okay to follow. Okay, so I have nothing else to present. You have now all the materials to take the exam, because nothing for the exam comes from the presentation. So, you know, when you are ready, you can start studying, and of course, if you have any questions, you can definitely write to me, and I'm more than happy to help. Of course, not provide you the correct answers, but if you have any doubts or don't know where to look for, or a little bit unsure about some of the answers, then of course I'm more than happy to answer or guide you to the right place, and that's no problem. Okay, if there's nothing else, then good luck with your homeworks, some last stretches, and I'll see you all next week in person. Okay, bye.